Hello all, a very good day to all of you. In this session, we will discuss all the questions that have come from analog circuits in 2016 GATE examination for instrumentation branch. Okay, so in 2016, right, there are total 9 questions that have come from this subject. 4 are of 1 mark and 5 are of 2 marks. So in total, 14 marks have been asked from this particular subject in GATE 2016 examination. Okay, let us discuss all the question one by one. The first question is, the diode used in the circuit below is an ideal diode, right? Ideal diode. The voltage drop VAB across 1 kilo ohm resistor is what? Okay, so first of all, let us understand very quickly what is the ideal diode, right? So the symbol of a diode is like this, right? So it have two terminal, one is called anode, another is called cathode, right? It have two modes of operation. One is called forward bias. So when I can say the ideal diode is in forward bias is when the current through the diode, nothing but ID, going from anode to cathode. If current through the diode is greater than 0, right? Then the voltage drop, nothing but V anode minus V cathode, is equal to 0. So I can say when the current flowing through the diode is greater than 0, it will act as a short circuit because the voltage drop is 0. What is the other mode is reverse bias. So when I can say the ideal diode is in reverse bias, when Vd is nothing but V anode minus V cathode is less than 0, right? Then I can say my diode is in reverse bias. In that condition, the current to the diode is equal to 0, or I can say it will be like a open circuit. Okay, this is the behavior of a ideal diode. Okay, so with this understanding, let us solve the question. So initially, we do not know whether a diode is reverse bias or forward bias, right? So first assume that, let's assume something, okay? Assume diode D is forward bias. So I can assume anything, right? Later I will check my assumption. So if my diode is forward bias, right, it will be like a short circuit. So let us build the equivalent circuit. 3 volt, right? This is point A. I have a 1 kilo ohm resistor. Point B. Point B. Then diode will be like a short circuit, right? Because it is forward bias. This is our assumption is forward bias, right? So then we have a 5 kilo ohm resistor. Then I have 1 milliampere of current. Okay, this is grounded. Now, with this assumption, let us calculate the current through the diode. Okay, so for that, let us put the nodal equation at this particular point. Okay, let us, the node will be X. Okay, let us put a nodal equation at node X. Okay, so then in this node, okay, let the voltage be V, Vx. So Vx minus 3 by 1k is the this current, right? Plus Vx minus 0 by 5k, right? Current coming to the load is 1 milliampere, 1 milliampere is equal to 0, right? This implies Vx minus 3 by 1k plus Vx by 5k is equal to 1 milliampere. Okay. Now simplifies. If I multiply both sides by 5k, right, I will get 5 into Vx minus 3 plus Vx is equal to 1 milliampere into 5k is 5, right? 5. Simplifies 5Vx minus plus Vx is equal to 6Vx plus 15 is equal to 5. Simplifies Vx is equal to minus 10 by 6. Okay, is equal to how much? 10 by 6. 1.66. Okay, so if Vx is minus 1.66, right, then so here if you see it is actually there is a mistake in the circuit, right? So this is actually 6Vx minus 15, right? This is minus 15. This implies 6Vx is equal to 20. This is equal to 20 by 6, right? 20 by 6 is equal to 3.33. Okay, so this potential here is 3.33 volt, right? So now with this we have assumed that diode is forward bias, right? So let us verify the assumption, right? If diode is forward bias, the current through diode should be greater than 0, right? So what is current through diode? ID is equal to 3 volt minus 3.33 divided by 1k, okay, so minus 0.33 milliampere, right? So the diode is, the current is flowing in the opposite direction, right? So which is not possible, right? So the assumption of forward bias is not true, because if it would have been in forward bias, then the current through the diode should be greater than 0, right? Now the current through diode have come less than 0, right? So the diode is forward bias is assumption is not correct. So assumption of forward bias is wrong. Okay, so diode is reverse bias. Okay, so with the reverse bias assumption, right, let us build a circuit now. Since we come to the conclusion that diode is reverse bias, right, then I have to replace it with the open circuit, right? Open circuit. This is the point A, this is the point B, right? This is 3 volt. Then we have a 5 kilo ohm resistor in 1 milliampere, right? So you see the question is asked is we need to calculate the voltage drop across VAB, right? So here you see, since it is open, the current through this will be 0. So since it is open, ID is equal to 0. So VAB is equal to ID into resistance is 1k, 0, right? So because the current is 0, so the voltage drop across the resistor nothing but VAB is 0. Okay, so the answer should be 0 volt, because diode is reverse bias, it's open, no current flowing through the 1k resistor, so the voltage drop is equal to 0. The next question. So in the circuit below, right, the op-amp is ideal, the output voltage V0 in volt, right? Very easy question this is, right? First let's build the Thevenin equivalent looking into the left side, right? If I look into the left side, what I have is okay, see 2 volt, 20k, this is 20k. Okay, so I want my Thevenin's equivalent at this terminal, right? So what is VTH? VTH is 2 into 20k divided by 40k, so equal to 1 volt, right? What is my RTH? RTH is the resistance looking into the 20k. So when I want to find out RTH, right, my voltage source will be short circuited, so my RTH will be 20k in parallel to 20k equal to 10k, right? So this circuit can be replaced by a voltage VTH in series with RTH, right? So let us replace this. So I will replace this one with a voltage source VTH in series with RTH, right? So let us replace this with the voltage source VTH. In this case, it is 1 volt. 1 volt in series with a resistance that is here is 10k. 10k. So I have a 10k resistance in series again. Okay. So then we have minus plus 10k, right? Is it 10k? Right? Then we have 20k. 20k. This is V0, right? So now we'll calculate the V0, right? Since we can see some part of my output is getting fed back to the negative terminal, so the op-amp is operating in negative feedback, right? So whenever my op-amp is operating in negative feedback, right, we know it obeys a principle called virtual ground, which means the voltage at negative terminal is equal to voltage at positive terminal, right? So in this case, since the voltage at positive terminal is 0, right, ground is connected here, so it is 0, so equal to 0, right? Now let us apply a nodal equation at negative terminal. Okay, let us apply nodal at negative terminal, right? Here the potential is 0, right? So 0 minus VTH is 1 volt by 20k plus 0 minus V0 by 20k is equal to 0, right? This implies V0 is equal to minus 1 into 20k divided by 20k is equal to minus 1 volt. Okay, so the answer is minus 1 volt. Very easy question, right? Next question. In the circuit given below, D1 and D2 have a forward bias drop of 0.6 volt, right? 0.6 volt. Then the op-amp usually is ideal, right? Then the magnitude of negative peak voltage of V0 is, right? So first thing is, initially I don't know the diodes are reverse bias or forward bias. Okay, so if I don't know anything, let us put it open circuit, right? So if you put it open circuit, right? So in positive half cycle, right? Positive half cycle. Half cycle, right? Since D2 and D1 are open, I am assuming, because I don't know the status of the diodes, right? So since I am assuming D1 and D2 are open, right? So it behaves like a comparator, right? During positive half cycle, right? B positive, B negative is positive here. B ground is already 0. So 0. So V positive is 0, right? P negative is greater than 0, right? Since V negative greater than V positive, so my output here will be minus V set, right? V out will be minus V set, right? Now, since I'll get minus V set here, this will make D1 forward bias and D2 reverse bias. If you get minus V set here, right? So negative connected to the cathode, make it forward bias, and D2 will be reverse bias. Okay. So now if you build the equivalent circuit, right? Okay. So D2 is open, 16K. Then since D1 is forward bias, right? Drop of 0.6 volt, right? There will be a drop like this of 0.6 volt, right? Because this is positive, this is negative. Then I have my output here, V0, right? So you can see clearly, right? The op-amp is now operating in negative feedback because some part of my output is feeded back to the negative terminal. So this means from here I can know op-amp in negative feedback. Negative feedback. Right? So when op-amp is negative feedback, right? What is V out? V out is equal to minus R2 by R1 into V in is equal to minus 10K by 10K is 1 into V in. Right or not? So then V1 is like a 1 volt sinusoid, right? Here output will be like this. This is my V in, positive half cycle, right? This is 1 volt, right? This is my V in. What is my V out? V out will be negative, right? 1 volt. Minus 1 volt, right? So this is the V out I expect during my positive half cycle. Okay. So what is the magnitude of negative peak? So negative peak here is minus 1 volt, right? So the magnitude of negative peak will be minus 1 volt. Okay. What will happen in forward in negative half cycle? In negative half cycle, okay. Since I don't know the condition of the diode, okay, we assume it is open. So then V negative will be negative, V positive is equal to 0. So since V positive is more than V negative, so I am expecting a plus V set here, right? So it will give me plus V set. So when there is a plus V set here, right, it will reverse bias. D1 will be reverse, D2 will be forward, right? What will my equivalent circuit? Minus plus, right? My D1 will be forward bias, right? And forward bias I will replace it with a 0.6 volt, right? And there is a resistance, right? It is connected to here. And D1 is reverse bias, so it's open. Okay, this is my V0. Okay, so we see since it is open, right? This is ground, right? So my V0 is right. Since it is open, this is my V in, this is my ground. Okay. So since there is negative feedback, right? So V positive is equal to V negative is equal to 0 volt. So 0 volt is here and it is open here, right? So no current will flow, right? So V0 will be 0, right? So during positive half cycle, my V out will be minus V in, and during my negative half cycle, my V out will be 0, right? So the negative peak is nothing but minus 1 volt. So the minus 1 volt is the answer. This is the next question. In the circuit given below, right, each input terminal of op-amp draws a bias current of 10 nanoampere, right? 10 nanoampere. So the effect due to the input bias current on the output voltage will be 0 if R is what? Suppose there is a 10 nanoampere current flowing. So here also there is a 10 nanoampere current flowing, right? So first thing is, let us calculate V01 due to 10 nanoampere I bias current, in negative terminal. Okay, so I am assuming only current is there in the negative terminal. Okay, so current is not there here. Okay, so in that case, what is the output voltage? So since there is a negative feedback, V negative is equal to V positive is equal to 0 volt. So let's apply nodal here. Nodal. Okay, current coming in is minus 10 nanoampere plus 0 minus V0 by 60K is equal to 0. This implies V0 is equal to 8 minus 10 nanoampere into 60K. Okay, V01. V01 is the voltage at the output due to the bias current at the negative terminal, right? Now let V02 is the voltage due to bias current in positive terminal. Okay, how it will be? So you see, now current is there in the here 10 ampere, right? So what is the voltage V positive? V positive is nothing but V positive is equal to 10 nanoampere into R. Okay. What is V0? V0 is nothing but V positive into 1 plus R2 by R1, right? 60K by 30K. Okay. So how much it will be? Equal to 10 nanoampere into R into 1 plus 60K by 30K, right? Now, in order to make the output voltage 0, right? What is V output? V output is equal to V0 is equal to V output due to the input bias current at the negative terminal plus V output due to the input bias current at the positive terminal. Okay, so is equal to what is V01 minus 10 nanoampere into 60K plus this is 10 nanoampere into R 1 plus 60K by 30K equal to 0, right? This implies 10 nano into 60K, right, is equal to 10 nano into R into 90K by 60K, right? So this get cancelled, right? So what is R? R is equal to 60K into 60K, right, divided by 90K, right? So what will be the R? R will be equal to but So here it is 30K actually. 30K, right? 30 into 60. It is 30 and 60 by 90K, right? So let's calculate. So it's equal to 30K into 60K divided by 90K. 20K. Right? So if we put a resistance of 20K here, then the output voltage V0 due to the input bias currents will be 0. Right? This is a very easy question. Now, next question is, an ideal op-amp is used to realize a differential amplifier given in the circuit below, having a gain of 10, right? So given differential gain is 10, right? If X is 0.025, right? What is the CMRR? Okay, CMRR is nothing but gain means 20 log differential gain by common mode gain. Okay, so we know CMRR is equal to 20 log differential gain by common mode gain, right? So thing is how to calculate differential gain and common mode gain. Okay, so since here V1 and V2 are there, the output here is equal to V0 equal to the output due to V1 plus the output due to V2. Okay, so I can say when V1 is there, the gain is A1. So A1 into V1. This is the output voltage. Only input voltage V1 is there, right? And V2 is 0, right? Plus A2 times V2. So this factor is nothing but the output voltage. Only V2 is there. V1 is not there. Okay. So output is sum of A1 V1 plus A2 V2. See, I am just using a superposition theorem. Okay. This is the total output due to V1 and V2. Then we know in op-amp the output is also nothing but differential gain into the differential input plus common mode gain into the common mode input. It's also right? So output is because of V1 and V2, right? Also the output can be expressed in terms of differential output and common mode output, right? And what is VID? What is VID? VID is nothing but V1 minus V2. What is VCM? VCM is equal to V1 plus V2 by 2. Okay. So putting this thing in the above equation, V0 is equal to A1 V1 plus A2 V2 equal to AD into what is VID? VID is nothing but V1 minus V2 plus what is ACM? ACM is nothing but ACM into what is VCM? VCM is V1 plus V2 by 2. Right? Now let us solve the equation. Okay, let's take to this side. So 2A1 V1 plus 2A2 V2, okay, is equal to 2AD into V1 minus V2 plus SCM into V1 plus V2. Clear? So now you see equal to 2A1 into V1 plus 2A2 into V2 equal to 2AD into V1 plus SCM into V1, right? Plus SCM into V2 minus 2AD into V2, right? So if you compare this equation, right, V1 corresponding term is V1. So if I have to equate the two terms, so it will be 2A1 equal to 2AD plus SCM, right? This is equation 1. If you compare the V2 term, right? 2A2 equal to SCM minus 2AD. Clear? This is equation 2. Okay. So let us add equation 1 and 2. To add equation 1 plus equation 2, right? What will have? Left side we have 2n plus 2a2. So 2 into a1 plus a2, right? Right side we have 2acm equal to 2acm. This implies acm is equal to a1 plus a2. Okay, a1 is the voltage gain only when v1 is present. A2 is the voltage gain only when v2 is present, right? This is the one important equation for calculating SCM, right? Now, what is ADM? Okay, so for that you have to subtract 1 minus 2. We subtract 1 minus 2. 2 into a1 minus a2 left side. 2 into a1 minus a2 in left side. Now, here we get 2AD plus 2AD is 4AD. 4AD, right? Simplest AD is equal to a1 minus a2, okay, divided by 2. Okay, this is one of the most important equation. Okay, so to calculate SCM and AD, we need to calculate A1 and A2, right? If you have A1 and A2, I can calculate SCM and AD. Okay, so first calculate A1. A1 is V0 1 when only V1 is present, right? V2 is equal to 0, right? So when V2 is equal to 0, right? So let us put this is 0. Zero volt means it is grounded, right? So this is 0 means this is 0. Here I got 0 volt, right? So because of Bhaskell ground principle, so here also I got 0 volt, right? What is the output? The output will be equal to 0 minus V1 by 10 into 1 minus x k plus 0 minus VO by 100 into 1 plus x k 0. Okay, this implies V0 equal to, right, minus 100 into 1 plus x divided by 10 into 1 minus x into V1, right? Now, this implies V0 by V1 is the gain A1 equal to minus 100 into 1 plus x is how much? X is given 0.25, 0.25 divided by 10 into 1 minus x, x is 0.25. Calculate A1. A1 is nothing but 10 into 1 plus 1.25 divided by 1 minus 0.25. I got 16.66. Okay, so I got A1 is equal to 16.66. Okay, so I got here A1 is equal to 16.66. Okay, let's calculate A2. So A2 is the gain. A2 is the gain, right? When V2 is there, gain due to V2. gain due to V2, V1 is equal to 0. Okay, let the output will be V02. Okay, so you see here it is 0, right? V1 is equal to 0 volt. That means I will make it to ground, right? now V positive is equal to V2 into 100 into 1 minus x k xk, right? 1 minus xk divided by 10 into 1 plus x k plus 100 into 1 minus xk. Okay, so k get cancelled. So I got V2 into 100 into 1 minus x divided by 10 into 1 plus x plus 100 into 1 minus x. Okay, this is my V plus. Okay, so if I put x is equal to 0.25, how much I will get? 100 into 1 minus 0.25, right, divided by 10 into 1.25, right, plus 100 into 1 minus 0.25. 0.85, 0.85 then V2. Okay, because of virtual ground, right, we know V negative will be positive, right, due to virtual ground. So V negative is equal to V positive equal to 0.857 V2. Okay, now put a nodal at V negative. Nodal at V negative is V negative by 10 into 1 minus x k plus V negative minus V0 minus V0 by 100 1 plus x into k 0, right? So V negative by 0, the 10 plus into 1 minus x k, V negative into minus V0 by this k. That's right. Okay. So this is equal to V negative into 1 by 10 into 1 minus x plus 1 by 100 into 1 plus x is equal to V0 by 100 into 1 plus x. Okay. So in place V0 is equal to 100 will go aside. Okay. V negative into 1 plus 100 into 1 plus x divided by 10 into 1 minus x, right? So now gain will be equal to, now V0 is equal to V negative means 0.857 V2 equal to 0.857 into V2 into 1 plus 10 into 1.25 divided by 1 minus 0.25, 17.6, okay, into 17.66, right? So V0 by V2 is equal to A2 is equal to into 0.857, 15.6, 14. Okay, this is my A2. So I got A1 is equal to 16.66, A2 is equal to 15.14. Okay, so what is AD? AD is nothing but A1 minus A2, right? AD is given by A1 minus A2 by 2, right? And SCM is equal to A1 plus A2. Okay, so 2.66 plus 14. Okay, is equal to 2.66 plus 15.14, 31.8. Okay, what is, so A1 is negative, right? A1 is negative. A1 is negative, right? A1 is should be negative. Negative. This is gain is negative here. So A1 is negative. So I'll put minus this plus this. So it will be minus 16.66 plus 15.14 equal to 1.552. 1.52. What is A1 minus A2 by 2? Think but here. So 16.66 plus 15.14 divided by 2. So I got 9. Okay. So what is now CMRR is 20 log AD by SCM. Okay. So 20 log AD is 10.9 divided by 1.52. So we got 40.4 dB. Okay, so the answer should be 40.4 dB. Okay, this is the next question. So in the circuit given below, right, the op-amp is ideal if input Vx is a sinusoid, right? To ensure Vy is equal to Vx, Vy is equal to Vx, what is the value of Cn, right? Plus Cn. Okay, so to ensure Vy is equal to Vx. Okay, so first thing is, let's apply a nodal at the positive terminal. Okay, since there is negative feedback, right? Since there is a negative feedback, right? V positive is equal to V negative, but let us put a nodal at the positive terminal. Okay, so Vy minus Vx by R plus Vy into the impedance of this is 1 by Sc, so it will go Vy by, it should be Vy by 1 by Sc, so let it be C. Okay, 1 by Sc. So I can it will go up, so it will become into S into C, where C is 1 nanofarad. Okay, I am putting intentional 1 nanofarad. Okay, plus Vi minus V0, Vi minus V0 into 1 by Scn is equal to Scn, right? This is the first equation. Okay, so this. Also, if you put a nodal equation at this point, right, what will you get? nodal at V negative, will get this point is this point Vy. So Vy by 1k plus Vy minus V0 by 10k equal to 0, right? So what is V0? V0 is equal to, right, 10k into Vy plus, sorry, V0 equal to, okay, 10k is equal to 11 Vy. V0 by 10k is equal to V0 by 10k is equal to Vy by 10k plus Vy by 1k. So this implies 0 is equal to 10k will go outside, we will get 11 Vy, right? Let's put this V0 in the above equation 0. Okay, so this implies this equation will become Vy Vx by R plus Vy into Sc plus Vy minus V0. So what is V0? V0 is nothing but Vy minus V0 Vy minus V0 is 11 Vy, right, into Sc and equal to 0, right? So in the question it is given that Vy is equal to Vx. Okay, we have to find out the condition that ensure Vy is equal to Vx. So if Vy is equal to Vx, then this will go 0, 0. Then we have Vy into Sc plus minus 10 into Vy into Scn, right? So Vy got cancelled. Okay, I got full 0. So we got Sc is equal to 10 into Sc n, right? So this implies Cn equal to C by 10. What is C? C is equal to 1 nanofarad divided by 10 is equal to 0.1 nanofarad. Okay, is equal to nothing but 100 picofarad. The answer should be 100 picofarad. Okay, so very easy question. This is the next question. So in this question, in the circuit given below, the op-amp is ideal, then the value of current IL should be how much? Okay, so it have both negative and positive feedback, right? It have both negative and positive feedback, right? But the feedback factor for negative VG is equal to 100k V0, right? V0 into 100k by 100k by 100k plus 100k equal to 1 by 2, right? What is beta positive? Is nothing but V0 to positive potential is equal to RL parallel to 10k divided by RL parallel to 10k plus 10k, right? So definitely the less than half, right? So since beta negative is greater than to beta positive, feedback factor for negative terminal is more than the feedback factor for positive terminal. So the overall feedback is negative feedback. Okay. So since it is negative feedback, right, I can say V negative is equal to V positive. This is called virtual ground principle, right? So V negative is equal to V positive. Okay. Now let us put a equation here, nodal equation here. Okay. This is suppose V positive only. Okay. V negative will be positive. Okay. So this point B. So apply nodal at V negative. Okay. V negative minus by 100K plus V negative plus V negative minus V0 equal to 0, right? So V0 is equal to V0 by 100K is equal to V negative by 100K plus V negative by 100K. So this implies V0 is equal to 2 V negative. Okay, but since V negative is equal to V positive, I can write 2 into V positive also, right? This is my V0. Okay. Now let's put a nodal equation at positive terminal. So nodal at positive terminal. Okay. So here you see V positive minus 1 by 10K. The current going away is plus IL, right? Plus IL, because current going away of the node is IL plus V positive minus V0 by 10K, 0, right? Now IL into 10K, right? 10K we multiply all these side equal to V positive minus 1 plus V positive minus V0, right? Is equal to 2 V positive minus V0 minus 1 equal to IL into 10K. Here, so also you know V0 is equal to 2 V positive. So let's put 2 V positive. What is V positive? V is nothing but 2 V positive minus 1 equal to IL into 10K. Okay. So IL is equal to minus 1 by 10K minus 0.1 milliampere. So is given IL in microampere asking, right? Microampere. So 0.1 milliampere is equal to 0.1 into 1000 minus 6 is equal to minus 100 microampere. So the answer should be minus 100 microampere. Okay, it's very easy question it is. Okay, next question. Okay, so this is a very nice question, right? The comparator's output is 1 when, so the comparator is given when V1 is greater, output is greater than 1, when output is equal to 1, when input is greater than 0, right? For the comparator, the output is equal to 1 when input is greater than 0, right? And the output is equal to 0 when input is less than 0, right? The exclusive OR gate and unity gain low pass filter given in the circuit are ideal, right? It's ideal low pass filter and ideal XOR gate. Okay. Then the logic output voltages of exclusive OR gates are 0 and 5 volt, right? Here I'll get 0 or 5 volt, right? The cutoff frequency of the low pass filter is 0.1 Hz. Okay. Then for V1 is equal to this, V2 is equal to this, what is the value of V0? Okay. This is a very easy question and nice question. Okay. So two things you have to understand. Okay. For the input, suppose V2, right? the time, right? So this time t at which it will become 100 degree, right? So it will be 0 degree, right? It will 0 here. At time, sometime it will become 0, right? So it will become sine v2 is equal to sine 3000 t. So I can say sine theta. Okay. So it will be 0, means it will 0 again when theta is equal to, so it will be 0 when theta is equal to 180 degree, right? So it will 0 at 0, theta is equal to 0. Again it will 0 at 180 degree. Again it will 0 at 360 degree, right? So at theta is 180 degree, it will 0. Theta is here given is 3000 t is equal to 180 degree, right? So what is t? T is nothing but here t by 2, here t by 2, right? T by 2. So t by 2 is equal to 180 divided by 3000 is equal to 60 millisecond is my half time period, right? Half time period. That's you understand. Second thing is V1 is, right? V1 is sine 370 plus 30 degrees. That means we'll start little early, right? Like this, continue, right? This is V1, right? So V1 is equal to, right, sine 3000 t plus 36 degree. So it will be 0 like here is t by 2, right? T by 2, right? Here it will be 3000 into t plus 36 is equal to 180, right? And only it will be 0 here. So if you calculate t is equal to 180 minus 36 divided by 3000. How much it is? 180 minus 36 divided by 3 is 14 millisecond. So here it will become 48 millisecond, right? 48 milli, right? Here it is 60 milli, right? Here it is 120 milli, right? So here 48 plus 60 will be equal to 108, right? Here 48 minus 60 is minus 12, right? So it will start from like this. So V1 is like this, V2 is like this. Okay. Now plot V1 and V2. Let's take a plot. Okay. Let's first plot V1. First plot V2. What is V1 and V2? V1. Okay. First plot V2. Forward V2. Okay. V2. Okay. This is V2. Okay. This is 0. This is 1 standard. This is 60 millisecond, right? This is 60 millisecond. Milli. This is 60 plus 60 is 120 milli, right? What is V? So if V2 is like this, right? What will be the output here? This is suppose V02. Okay. Will V02. Let us okay. Let us plot the V1 also. So plot V1 in different color. Okay. So V1 you see it become 48 millisecond, right? 40 millisecond will be 0. So it will be 0, 48. So 120 minus 12 will be here. Okay, again it will be 0 here. Okay, we start from little bit early. Start little bit early. So it will be like this. Okay, then it will be okay. This is like V1. V1. Okay. If V2 is like this, what is V02? This is V01. Okay. What is V02? What is V01? First let's calculate V01. V01 is how much? This is V01. So output will be 1 when my V1 is positive, right? So V1 will be like this. Okay. Same. This is 48 milli. This is 120 minus 12 is minus 12. Minus 12. 48 milli. This is how much? 100 minus 12. 108. This point is 108 milli. This is also 108 milli. Right? So this will be my V1. What will be my V2? So V2 will be V2 if I want to plot here. Okay, I will plot here V2. V02. Not here. Okay. Plot here only. This is V01. Let's plot V02. V02 is when V2 is positive, then it is 1. Okay. Again, it is positive here. 2. To here. Okay. This is my V02. This is 60 millisecond. Okay. This is 120 millisecond. Okay. Again, I'll get 120 plus 60 is 180. Like that it will go. Okay. So now, since it's exclusive OR, right? It's exclusive OR. What is the output? The output will be in XOR, right? XOR. The output, you know, in XOR, the output will be a. Here, two inputs are V01, V02, right? So you see, here inputs are V01, V02. Okay. What is XOR output? XOR V01, V02. This is output V. This is out. This is V out. V out will be equal to 0, 0, 0, 1, 1, 0, 1, 1. Right? So output will be 1 only when one input is 1, 1, 1, 0. So okay. So either V01 is 1 or V02 is 1, output will be 1. This is my XOR output. Okay. Here you see, if you want to plot the output, right? Here. Okay, this is my output. Okay, the output here is for this point is Vx. Okay, this point is I'm putting here. I'm looking at another color. This is Vx. Vx. Okay, so you see, both V01 and V02 is positive. Sorry, in this direction, both are 1, so output is 0, right? So output is 0, and for this duration V0 is 1, V0 is 0, that means 0 1, so output will be 0. So for this duration I will get output is equal to 5, right? It's 5 volt, because extra is giving 5 volt. Okay, again this is 60 millisecond, right? 60 milli, 0, 60 minus, this is 60 minus 48, 48, right? 48, clear? Again you see, for this duration V01 is 1, V02 is 0, so output will be 1 and 0 is 1. So this duration, okay, here it will be 120, here it will be 108, right? So this will repeat like this. Okay, again at the 180 I'll get like this, 120 plus 60, 180, 180 minus 12 is 168, right? Like that it will go. Okay, it's milli, okay, in milli, all milli. Okay, this will repeat like this. Okay, so at this Vx I get a waveform like this. Okay, of period of 60 millisecond, width is having 12 millisecond, right or not? So I got at the output pulse Vx, I got Vx I got 0, then at 60, at 120, then at 180, like that. So at 60 I got a, this width is 12 milli, okay, height is 5 volt. Again at 120 I got a width of same 5 volt. Again 180 I got like this, okay, so again 5 volt, okay. So this will continue, right? So the waveform at the Vx is this one, right? Then what is V0? So you know, when we have a rectangular pulse like this, okay, then V0 will consist of DC plus A1 into some fundamental of frequency, A1 sin F1t plus A2, you know, DC component plus frequency frequency component of F1, then so my output will be here DC plus high frequency, right? High frequency means the fundamental frequency F1 component plus F2 component. F2 is nothing but 2F2. It will look like this. Okay, what is F1 here? F1 here is 1 by time period is 60 millisecond. Here you see, for every 60 millisecond that thing is repeating. Okay, so 60 milli, 1 by 60 milli is nothing but 1 by 60 milli is equal to 16 hertz. 16 hertz. Okay, so the fundamental frequency component is having 16 hertz. F2 is 16 into 2. This is actually 16.66 hertz. Okay, so F1 is 16.66 hertz. F2 is into 2 is nothing but F1 is this. F2 will be 32.33.33. Then it will continue. Okay, and here I am having low pass filter. The low pass filter frequency is having 0.1 hertz. Okay, but the fundamental frequency is having 16 hertz. Okay, so this low pass filter is having a cutoff frequency of only 0.1 hertz. Okay, so this low pass filter will not pass any frequency above 0.1 hertz, but my minimum frequency is nothing but the fundamental frequency is having 16 hertz. Okay, so my output here is Vx. Okay, this is Vx. So my output here is equal to only DC of Vx. Okay, because all others F1, F2, F3 all will be not be passed by my low pass filter. So my low pass filter will only pass the DC component of Vx, DC component of Vs. Okay, F1 is having 16 hertz, which is the higher than the cutoff frequency of my low pass filter. So my output will be DC of Vx. Okay, what is the DC of Vx? DC of Vx, we know DC of Vx is equal to 1 by time period into 0 to t Vx dt, right? So here 1 by time period is 60 millisecond, 60 millisecond into 0 to 2. So in 0 to t, only from 48 to 60, right? Only from 48 to 60 milli, I am having the signal of 5 volt into dt. So I will have 1 by 60 milli into 5 of 60 minus 48 is 12 milli, right? So 12 milli into 5 60. So all get cancelled. I got 1 volt. So 1 volt is the DC magnitude of my waveform at Vx. DC of this waveform is, okay, having 1 volt. Okay, 1 volt. So at the output V0, I'll get 1 volt. Okay, so the answer should be 1 volt. Okay, very easy question, but you have to draw the circuit, right? Then you understand that I'll get a pulse of 60 millisecond of width 12 millisecond. Okay, then from here at this point I get fundamental DC, fundamental and the second harmonic, third harmonic, all will be only the DC will be passed, and the fundamental, second harmonic, third harmonic, all will be blocked. So I'll get DC of Vx nothing but 1 volt at the output. Let us see the next question. So in this question, given, right, the circuit shown below, the op-amp is ideal, right? The op-amp is ideal, and the sensor is RTD, okay, whose resistance is given R theta is equal to 100 into 1 plus 0.004 theta ohm, okay, but theta is the temperature in degree Celsius, okay. Then the output sensitivity millivolt per degree Celsius is what, okay. So here the output is, suppose the 5 volt is present here, right? So if 5 volt is here, what is the voltage here? The voltage here will be, let's do one thing. So let us see, if my output V01 is only due to 5 volt at, okay, actually 5 volt is there both negative and positive terminal, okay. So I can use, let us take this point is how much V positive, V positive is equal to how much, this is minus 5 into 10 by 10, so it's minus equal to minus 2.5 equal to minus 5 into 10k divided by 10k plus 10k is equal to minus 5 by 2 is minus 2.5 volt, okay. So this due to virtual ground principle, right? If I apply a nodal equation here, right, P negative is equal to P positive is equal to minus 2.5 volt, right? Now apply a nodal at P negative. So I got P negative minus 5 volt, minus means, sorry, P negative minus 5 means plus 5 by 1k plus P negative minus V0, P negative minus V0 divided by R theta equal to 0, right? So V negative minus 5 means plus 5 by 1k plus V negative minus V0 by theta is equal to 0. This implies V0 by R theta equal to V negative by R theta plus V negative by 1k plus 5 by 1k right? So now this is what's equal to V0 is equal to R theta into V minus, so is equal to V minus into R theta by R theta is equal to V minus plus what is V minus by 1k, V minus by 1k into R theta into, see this R theta will go this side, right? V0 will be V0 is equal to R theta into V minus by R theta plus V minus by 1k plus 5 by 1k, right? This is equal to, this implies V0 is equal to V minus into R theta by R theta got cancelled, is equal to what, V negative, okay, plus V negative into by 1k plus V negative by 1k into R theta is given 1000 into 1 plus 0.004 theta, okay, 1000 into 1 plus 0.004 theta, right, plus 5 by 1k into R theta will be equal to 1000 into 1 plus 0.004 theta, okay. So the simplest V0 is equal to V negative plus V negative by 1k got cancelled, is equal to V negative into 1 plus, okay, 0.004 theta, clear? 1 got cancelled plus 5 5 into 1 plus 0.004 theta, right? So this implies V negative plus V negative implies equal to, so V negative plus V negative, so V negative plus V negative, right? This one plus V negative into 0.004 theta plus 5 into 0.004 theta, okay. So we know V net is equal to minus 2.5 volt, right? To calculate that. So minus 2.5 is minus 5 plus minus 2.5 into 0.004 theta plus 5 plus 5 into 0.004 theta, okay. So this got cancel, minus 5 plus 2.5 is equal to plus 2.5 into 0.004 into 0.004 theta is V0, right? Simplest, the output sensitivity is nothing but d V0 by d theta, right? The change in output voltage by change in temperature is equal to 2.5 into 0.004 equal to how much? 2.5 into 0.004, 0.01 volt, right? 0.01 volt per degree centigrade, right? d by d theta. So this is nothing but output sensitivity, nothing but my output will vary by 0.01 volt if my temperature will change by 0.1 by 1 degree Celsius. Okay, if my temperature will change by 1 degree Celsius, my output will vary by 0.01 volt. Okay, this is the output sensitivity. My output will vary by 0.01 volt if my temperature changes by 1 degree Celsius. So answer is the output sensitivity is nothing but 0.01 volt per centigrade. So if you convert it to milli, it will be 10 millivolt per degree centigrade Celsius. Okay, the output is sensitivity is 10 millivolt by per degree Celsius. Okay, it's a very easy question. This is the next question. The photodiode in the figure below has an active sensitivity area, active sensing area of area is equal to 10 mm square, right? The photodiode sensitivity is given, okay, given 0.5 ampere per watt of the input power, right? Dark current is given 1 microampere, okay. Now the I to B converter has a sensitivity of 100 milliampere per microampere. Then for the input light of this, what is the output voltage? Okay. If I to B converter has a sensitivity of I to B is given 100 millivolt per microampere, right? Then for the input light of intensity 4 watt per meter square, what is the output voltage? Okay, so P input intensity equal to given 4 watt per meter square. So what is the power input? Power input is P intensity into the area given 4 watt per meter square. What is the area? Area is 10 mm square. So mm means millimeter, 10 power minus 3 the square, right? Square. So I got 40 microwatt, right? 40 microwatt is my input power. Okay. Then what is the current due to the light? The current generated is equal to the photosensitivity into the power input. So 0.5 ampere per watt into power input is 40 microwatt. But so I got 20 micro ampere, right? 20 microampere, right? So now what is the output voltage? So the output voltage is equal to sensitivity of I to B into my current generated. So 100 millivolt per microampere into 20 microampere. Okay, so this get cancel. I got 2 volt is my output, right? 2 volt is the output. So the answer should be 2 volt. It's a very easy question, right? You have to know only the units to get the answer. Okay, so I think that's all. So thank you guys, all of you.